Welcome to the CWI Part C practice questions, where I discuss the different questions that may come out of the CWI Part C exam. In this series, I will discuss the answers and the explanation to these answers and the clauses in which they can be found in the API 1104. This series will feature the API 1104 2021 edition, as you can see here. So these are 5 sets of CWI Part C questions for API 1104 that will help your preparation during that part of the CWI exam. So without further ado, let's get started.
For in-service welding, burn-through is unlikely if the pipe A is made of stainless steel, has a wall thickness greater than or equal to 0.25 inch or 6.4 mm, is pressurized to at least 15 psi or 103 kPa. Letter D is preheated prior to welding, or letter E is welded by a qualified welder. Now this question pertains to in-service welding of pipes, which is called upon in Annex B of API 1104. So as you can see, here is the Annex B or the normative references in API 1104 in-service welding. So this question is related more to the heat input of the weld and some concepts regarding the material characteristics of the weld. As you can see here, Annex B of API 1104 pertains to in-service welding. So by definition, in-service welding refers to welding of pressurized or flowing piping systems that contain crude, petroleum products, or fuel gases. So what are the instances where burn-through can happen? So it can happen when excessive penetration caused by the weld puddle is blown into the pipe or the fitting. So there are several factors that may affect this, such as the pipe material, thickness, and the welding heat input as well, as I've mentioned earlier. As you can see here in this 4th paragraph, burn-through is unlikely when installing an appurtenance if the wall thickness of the pipe is 0.25 inch or greater. Based from Annex B here, burn-through is unlikely to happen if the wall thickness of the pipe is greater than 0.25 inch and or provided that the electrode that is used is low hydrogen electrode type. The electrode types that are ending in 8, 5, and 6 digits. So from the choices, you can rule out letter A because it is made of stainless steel. So from the choices, you can also rule out letter A since stating the material only without information of the heat input and the pipe thickness cannot be a definitive answer. So here, you can rule that out. Letter C, pipes pressurized to at least 15 psi does not affect burn-through. So whatever the operating pressure of the pipe does not affect the welding discontinuity, that burn-through. So letter C here, preheating prior welding, preheating actually softens the pipe material or reduces its hardness. So in some ways, it can promote burn-through if preheating is not done properly. So letter E, welded by a qualified welder. So it doesn't matter if the welding these pipes must be done by qualified welder by passing the appropriate welder qualification tests. But it doesn't mean that burn-throughs will not happen in this situation. So, which leaves us to the answer here. If you done this by elimination, so that will leave us to this answer, letter B, as also referenced in Annex. As referenced also in Annex B of API 1104.
By the way, I just want to take a break from the video and remind you of the free Udemy course that I've put in the description down below. So it composes of CWI Part A lectures, the introduction for welding inspectors. So you can check out the description below for that free Udemy course. Now back to the video.
For in-service welding, which of the following conditions are required for hydrogen cracking to occur? Letter A, crack susceptible microstructure. Letter B, a weld discontinuity. Letter C, tensile stress acting on the weld. Letter D, all of the above. Letter E, Only A and C above. So this question also refers to in-service welding. The answer can be found in Annex B, point 1, General. This is under the general clauses of API 1104 Annex B. So in this paragraph, as you can see, hydrogen cracking can occur when there is hydrogen in the weld, development of a crack-susceptible microstructure, this one, and tensile stress acting on the weld. So as you know, the presence of hydrogen in the weld is possible because of moisture, since water is composed of, or 2 hydrogen molecules, I should say, and 1 oxygen molecule. Crack-susceptible microstructure, it refers to those materials with coarse grain structure, more common on high hardness materials and non-heat treated materials, because it is more susceptible to hydrogen cracking or cracking in general if heat treatment methods are not properly implemented to in those materials, and there is a tensile stress acting on the weld. So the last 2 points can be resolved with the use of heat treatment methods, is crack susceptible microstructure and the tensile stress, because residual stresses can be relieved by PWHT or heat treatment. So that leaves us with the answer here. Letter E, only A and C above. So a crack susceptible microstructure and tensile stress acting on the weld. So the weld discontinuity may or may not induce hydrogen cracking. So this is a very general statement. It will depend upon the discontinuity. The answer here is letter E. For welder qualifications of an in-service longitudinal seam weld on pipe with a 12-inch or 300 mm outside diameter and a wall thickness of 1 inch or 25 mm, which test specimen are required? So letter A, 2 tensile, 2 nick break, 2 root bends, and 2 face bends. Letter B, 2 tensile, 2 nick break, and 4 side bends. Letter C, 4 nick break, 4 face bends, and 4 macros. Letter D, 1 tensile, 1 nick break, and 2 side bends. Letter E, 1 tensile, 1 nick break, 1 face bend, and 1 root bend. There are separate guidelines for qualifying welders for an in-service welding, which is referred to in section B.3 of Annex B here. Testing of welded joints. Similar to other welding qualifications, there are requirements to the number of test specimen for in-service welding given here in table B.5. Looking at this table, you can see the total number of test specimen depending on the sleeve wall thickness of the pipe. So here it depends upon this wall thickness. So looking at this table, the wall thickness is 1 inch. So this row should be the answer here. 1 tensile, 1 nick break, and 2 side bends, a total of 4 tests. So looking at the answer here, it should be, so looking at the choices, or looking at the table and based from the choices, the answer here is letter D. 1 tensile, 1 nick break, and 2 side bends. The answer here is letter D. For in-service welds, the carbon equivalent of the material to which the procedure applies should be identified. Which of the following elements is not used to determine the carbon equivalency? So carbon is important for in-service welds because it determines the hardness of the said material. So different materials have different carbon equivalents depending on its chemical composition. So you can find this in the mill certificates of those materials. So letter A, copper. Letter B, nickel. Letter C, silicon. Letter D, vanadium. Letter E, chromium. This question can be answered as well if you are familiar with the equivalent carbon formula, in which if you are taking the CWI exam, you must be familiar as well. Don't worry, if you want to make sure as well, you can refer to the footnote of B2.2 Welding Procedure Specification under the annex of in-service welding. It's a bit small here, but this is the formula for the carbon equivalent, where the elements that will be considered in calculating equivalent carbon are indicated. So based from this formula, silicon is not included. So we can now conclude from this choices, that the answer here is letter C, silicon. Silicon is not used to determine the carbon equivalency. So it has different function for, I think, for deoxidizing the steel. It doesn't contribute much, or doesn't contribute to the carbon equivalent, and in general does not contribute to the hardness of the material. The company shall retain documentation of the qualification of welding inspectors, which shall include, but are not necessarily be limited to, A. Results of any qualification examination, B. Education and experience, C. Training, D. All of the above, E. None of the above. So for the qualification of welding personnel, it can be found in 8.3 of API 1104. Documentation of these personnel is necessary because it's not only important for safekeeping and legal purposes, but to also track if the qualified welders needed to be retested as well. So I think there is an expiration, so to speak, of the qualification of these welders if they are not using this specific welding procedure, or welding, not welding procedure, but a specific welding process. For example, GTAW or FCAW, they're not using it for a couple of months or for a couple of years. They need to be retested. So they need to be retested as well, because for example, if they have produced unsatisfactory welds, or just to maintain or to have a proper tracking of these welders. So as you can see here, the documentation of this qualification shall be retained by the company, and the information included therein or herein should be the education and experience, training, and the results, more importantly, or most importantly, the results of any qualification examination. So by that clause, the answer here is letter D, all of the above. All of these results must be kept in accordance with the company policy, or should be retained in accordance to API 1104.
There you have it. So that's 5 practice questions that will help you during the CWI Part C of the examination for API 1104. So if you want more guides regarding the CWI exam Part A, or some lectures regarding the CWI exam, or just become a better welding inspector by learning how to read welding procedure specification, identifying essential variables, and the like, you can check my channel, and the playlists are in this description. So if you like that video, please subscribe to my channel and comment down below for any questions. See you on the next one.